Our universe is not static. It is in a state of continuous and accelerating expansion, a phenomenon that makes it exceedingly difficult for scientists to pinpoint its actual size or define any clear boundaries. Despite the limits of our perception and instruments, humanity has taken enormous strides in understanding the cosmos. A pivotal moment in this journey came with the launch of the James Webb Space Telescope, an engineering marvel designed to look deeper into space and further back in time than any of its predecessors. Thanks to this revolutionary observatory, we are now able to gaze into the most distant reaches of space, capturing light that has traveled for billions of years. It allows us to witness galaxies as they were in the infancy of the universe. Since Webb began its mission, countless scientists, including prominent physicist Brian Cox, have shared insights that challenge our previous assumptions and expand our understanding of just how massive and mysterious our universe truly is. In the small segment of the universe that we are currently able to observe, researchers estimate the existence of roughly 2 trillion galaxies. This staggering number is based on data gathered from the local observable universe. And yet, it's widely accepted that this observable region, vast as it may seem, is only a minute fraction of what likely constitutes an infinite or near-infinite universe. It's humbling to realize that beyond the range of our most advanced instruments, there may lie vast stretches of space we can never detect or comprehend. Crucially, we are not detached from this universe. We are part of it. In fact, many philosophers and scientists suggest that humanity may represent a way in which the universe has developed the capacity to observe and understand itself. We are, quite literally, the cosmos become conscious, a powerful idea that redefines our role within the larger framework of existence. Thanks to the James Webb Telescope, we are not merely spectators. We are participants in a vast expedition of discovery. With every new image and data transmission, we inch closer to answering the timeless question: what is the true size and structure of the universe we inhabit? If you're fascinated by these cosmic revelations and want to stay updated on discoveries that reshape our view of reality, we invite you to subscribe to our channel. Don't forget to like this video and click the notification bell so you never miss the next chapter in this unfolding story of the universe. Let's begin with a relatable thought experiment to grasp the sheer size of space, starting with something familiar: Earth. If we traveled at a constant speed of 70 miles per hour, it would take about 15 days to complete a single lap around Earth's equator. At that same speed, it would take about 5 months to reach the Moon. To get to Mars at its closest point would require approximately 63 years, and to reach Neptune, the outermost planet in our solar system, it would take an astonishing 4,400 years. These figures alone provide a glimpse into the immense scale of our solar system. Now consider Voyager 1, the spacecraft launched in 1977. It travels at a velocity of 38,000 miles per hour, yet it didn't exit the solar system until 2012, 35 years after its launch. This milestone emphasizes just how vast and spread out the planets and celestial bodies are, even within our own solar system. And light, the fastest phenomenon we know, takes just over 8 minutes to travel from the Sun to Earth, and can circle our planet 7 times in a single second. Yet even light begins to seem sluggish when measured against the vast distances between stars and galaxies. While the solar system is already immense, it is minuscule compared to our galaxy, the Milky Way, which contains an estimated 300 billion stars. Many of these stars are believed to host their own planets, forming solar systems not unlike ours. Our nearest neighboring star system, Alpha Centauri, lies 4.3 light-years away. Even if we could travel at the speed of light, the fastest speed theoretically possible, it would still take over 4 years to reach it. But traveling at Voyager 1's speed, reaching Alpha Centauri would take approximately 70,000 years, nearly as long as the entire history of modern human civilization. That alone is enough to spark awe and curiosity about the universe's true extent. Let's now turn our gaze to a distant star known as VY Canis Majoris, also referred to as Veltar Rouge. Located about 640 light-years from Earth, it is one of the largest known stars. When you observe this star in the night sky, you are seeing light that left its surface more than 6 centuries ago, around 100 years before Christopher Columbus set sail for the Americas. That ancient light has traveled across the cosmos all this time, only now arriving at our planet. An extraordinary reminder of the immense temporal scales involved in space observation. Our radiosphere, or the spherical bubble created by all. The radio signals humanity has ever transmitted is just over 100 light-years in radius. So far, these degraded signals have reached about 15,000 star systems, a microscopic number compared to the hundreds of billions of stars in the Milky Way. If we scaled down the solar system to the size of a coin, like a quarter, the Milky Way would span the entire United States in comparison. Within that colossal galactic space lie around 300 billion star systems, and we are merely one of them, floating within an unimaginably vast ocean of stars and possibilities. But our galaxy is not alone. There are estimated to be at least 1 trillion other galaxies beyond the Milky Way. To conceptualize the number trillion, imagine gathering 1,000 cats. Now imagine 1,000 groups of those 1,000 cats. This gives you 1 million. Now take 1 million groups of those. That's a trillion. It's a number that defies our everyday comprehension. Among these countless galaxies, our closest neighbor is the Andromeda Galaxy, located 2.5 million light-years away. Andromeda is moving toward the Milky Way at a rapid pace. When it eventually collides with our galaxy billions of years from now, it will radically alter the night sky. Despite each galaxy containing hundreds of billions of stars, the vast distances between stars make direct collisions unlikely. Space, even during galactic mergers, remains mostly empty. Galaxies are not static. They are dynamic and evolving. They form groups, clusters, and even larger structures. Our local group includes dozens of galaxies, which is part of the Virgo cluster, containing over 1,500 galaxies. This, in turn, is within the Laniakea supercluster, an immense region spanning over 500 million light-years and containing around 100,000 galaxies. And yet Laniakea is still only a tiny fraction of the total cosmic structure. The observable universe holds an estimated 10 million similar superclusters, and even this number likely underrepresents the full extent of the cosmos. We also observe the cosmic microwave background radiation, the oldest detectable light in the universe, a relic from just 380,000 years after the Big Bang. This faint glow allows scientists to study the conditions of the early universe, providing a window into its origin and evolution. As we probe deeper, we encounter cosmic voids, vast regions of space where matter is extremely sparse. These voids can span hundreds of millions of light-years and appear almost empty, but they may eventually host the formation of new structures. Interwoven between these voids are cosmic filaments, the enormous strands of dark matter, gas, and dust that stretch across billions of light-years. These filaments form a kind of cosmic web, binding galaxies and galaxy clusters together under the force of gravity. This cosmic web forms an intricate, interconnected pattern, a tapestry of unimaginable proportions where superclusters link and galaxies migrate and evolve. Within this complex structure, the universe performs its ongoing ballet of creation and destruction. Phenomena such as supernovae scatter the building blocks of life, carbon, iron, oxygen, across interstellar space. Black holes, especially the supermassive ones at galactic centers, regulate galaxy formation and can launch jets of energy that span thousands of light-years. Even more enigmatic are quasars, incredibly bright objects powered by black holes feeding on matter in the early universe. These act as cosmic lighthouses, guiding us in studying ancient epochs of cosmic history. But perhaps the most tantalizing question of all is, what lies beyond the observable universe? There are undoubtedly galaxies out there whose light has not yet and may never reach Earth, due to the accelerating expansion of the universe. These distant regions are likely to remain forever invisible to us. According to current cosmological models, the entire universe may be at least 250 times larger than the portion we can observe, and some theories suggest it could be infinite. This possibility compels us to consider the profound implications of such vastness and our place within it. We, human beings, are living on a small rocky planet orbiting an average star in a remote corner of one galaxy among trillions. Yet from this tiny vantage point, we are capable of asking questions, seeking knowledge, and imagining the extraordinary scale of everything that exists. So, have you ever truly wondered how vast our universe really is? If this video has sparked even a small part of that curiosity within you, then we've taken one more step together in exploring the grand story of existence. Please feel free to share your thoughts or questions in the comments below. If you enjoyed this journey, give the video a like, share it with fellow explorers of the cosmos, and subscribe so you don't miss our next voyage into the stars. Thank you so much for watching, and until next time, keep looking up.